In these problems, we're given a bunch of exponential equations and we're asked to write these equations in the logarithmic form. In order to do this, you just need to do a simple trick of moving the base of your exponent to the other side and applying it as the base of the log. The easiest way to see this is through an example. So we have 27 to the 1/3 power is equal to 3. Well, we know the third root of 27 is 3, but how would you write that as a log? The way that you do that is you take that base, that number 27, and you would move that to the other side. So we're going to move that over here to the other side, put it inside the logarithm, write the word log here, and we'll keep our 3 right where it is, we'll keep our 1/3 right where it is. The only thing that's moving is the base of the exponent. You move it to the other side and write log. So let's see if we can do that again. We have 10 squared equals 100. Well, 10 is our base, so we're going to move that to the other side here, and it becomes the base of our logarithm. So in order to get that, we're going to have 2 left over from our old exponent equal to log base 10, just because the base of our exponent was 10, therefore the base of our logarithm will be 10, of 100. Same idea here, let's do it again. The base of this exponential equation, the base of this exponential term here is x. So we're going to take x, we're going to move it to the other side and make it the base of our logarithm. So a is what's left over on the left side, is equal to the log base x of 12. And finally, we have a much more complicated example here, but all the same rules apply. We have a plus b as one large term that's being raised to the 7x power. So that entire term is our base, which means we have to move it to the other side and make it the base of our logarithm. Left over on the left side, we have that 7x, which is what was previously in our exponent. That's just going to be out front by itself now. Then we have our log with base a plus b, because that was our base of our exponent, therefore it's the base of our log. And on the other side, it's what we had there originally, so 84x plus y. We're going to throw that in parentheses so that we don't have any confusion. And our final statement is going to be 7x equals the log base a plus b of 84x plus y. Just a graphic that you'll see above these notes, you have the log base b of x is equal to a, or if you put it in the exponential form, b to the a is equal to x. All they did is took that base of your logarithm and made it the base of your exponent. Otherwise, nothing else is changing, nothing else is moving. A couple things to take note of is that b is always going to be positive. The base of any exponent or the base of any logarithm is always going to be a positive number. It's going to be a positive number that is not equal to 1. Because if it was equal to 1, 1 to any power is just 1. So you're not going to have an equation, you're just going to have a constant. And finally, the result of your exponent, or the number you take a logarithm of, is also going to be positive. So x is always going to be greater than 0 in this equation. One thing to watch out for is that in many cases we have equations where we have y equals some base b to the x. So when I say x is greater than 0, a lot of times that x is actually referring to y in many equations. So you just have to look at the equation, but the result of an exponential term is always going to end up being positive. That's what the rule is stating here.